I have to wear glasses now, and they're really rubbish glasses, and I can only see things that are about 2 feet away, so apologies about that. I can't see anybody now. Quick show of hands, who was here a couple of years ago? Right, good. So I was also here 2 years ago as well, talking about the 153s, and I'm back here again now. Probably the key message that you probably took away from that presentation 2 years ago, thanks to Mr. Edgley, was that I really was quite scared of Big Bird out of Sesame Street when I was a child, and that is the key reason why the 153 VIUs are painted blue and not yellow. But I'm very keen that you go away with some different key messages today, John, so please take a note of that. Right, so as I said, here a couple of years ago, things have moved on quite a bit since then. Ooh. Good start. And I'm back to tell you a little bit more about sort of really where we've got to. Recap on how we've got to where we are. But the key thing really, what I want to get across today is what they can do and what they can do for you. And I'm sure there's a number of people in here who've had sort of first-hand experience of them. I'd be very sort of keen to hear of what your experiences are. But I really want to sort of get some other people to take those messages away as well. I want to give a bit of a view on how we might move to a national service as well. So at the moment it's primarily based in Eastern and Southern, and also touch on some of the challenges that we've had on the way, and also some of those challenges that still exist today as well that we still sort of need to overcome. And then wrap up at the end with a bit on sort of data exploitation, because at the end of the day, nothing is ever used, I don't think, in the way that it was originally intended, and I think the Class 153 VIUs is a cracking example of that. One thing I must say is that in this presentation I have plagiarised a number of photos from various people, and I don't want to go to prison for copyright infringement, so I just need to mention Josh Chambers from Eastern and also Sam Lowe from One Big Circle, who provided a number of these photographs, which will hopefully keep me out of trouble. Do I need to point this at that or at this? I'll just generally point at. So why change? So if you roll back the clock around about 3 years, two, well, I would say, sort of main drivers, and then a sort of tertiary driver as well. The two main drivers around asset safety and worker safety. We had the very unfortunate fatality of Tyler Byrne early 2021, who was undertaking an S&C inspection in Southern and was struck by a train whilst doing that. And there'd been lots of other incidents over a number of years, near misses as well, sort of reported around doing S&C inspection. And I think it'd be fair to say there's probably a number of more minor incidents, slip, trips and falls, etc., that probably weren't being reported. As Rob said in his opening speech today, there's also the big push to reduce red zone working as well. And then relating to asset safety, there'd been a number of derailments around in S&C as well. And one of the RAIB sort of common threads around that was sort of an inadequate inspection regime within Network Rail for S&C. Particularly, there being very little loaded geometry measurement of S&C as well. So they were the sort of two key drivers for this, and that sort of, the asset one culminated in the Sheffield derailment around sort of November 2020, I think it was, something like that, where failing of the fixings was shown to cause gauge widening, and a train came off there, but that wasn't easily detectable by just doing manual inspections, which weren't loaded, of course. Tertiary driver, as I said, there's sort of three drivers here. Tertiary driver is really that support to move more of towards a risk-based maintenance regime, which of course needs enhanced asset information to sort of underpin that. So the remit was set, and you can read that yourself. I think the key thing to sort of draw your attention to there is the 6 months. That was a pretty sort of challenging time frame. But basically that was sort of the remit that was handed over to me, and the sort of the instruction was crack on, which is great because that's the sort of way I quite like to work, really. So firstly, Southern and Eastern were the main customers for this, or the immediate customers for this. So we did a lot of work with Southern Eastern as the end users to define what their real sort of key requirements were. So they could focus on the what, and then we could focus on how we go about doing it. So the first sort of high level overall one was really to allow a person to do a BVI inspection of S&C at the comfort and the safety of their desk. Now, obviously with that comes a load of other sort of subsidiary requirements. You know, the image quality has got to be of the right level, the views that you get of the track has got to be of the, you know, coming in at the right angles, but also the functionality of the system that they use has got to be right as well. You know, it's got to be user-friendly, easy to use, and intuitive, I suppose, in the way that you do that, and also match the way that you would tend to do it on site as well, in terms of the way that sort of takes you through that. Some more sort of requirements as well. Southern particularly keen on having thermal imagery, obviously with all their conductor rail. Eastern very keen on having geometry because their driver was more around the asset safety. Locational accuracy, so repeat locational accuracy down to sort of sub 1 metre as well. If you've done inspections in S&C, knowing where that fault is needs to be a lot more accurate than when you're doing it in plain line, for example, because, you know, if you're one road out, that's going to cause you all sorts of problems when you go and try and fix it. Forward-facing video was another requirement as well, again to sort of get a bit of more of a view of what a patrol person would get. Key one was with getting data from the train to the end user within 24 hours as well. But really important was that wouldn't require any more processing. So as soon as it lands on their desktop, they can basically open it and they can use it. They don't need to do anything else at all. Then also it had to go anywhere. There was little point in rolling something out that could only inspect 25% of the S&C. Had to be able to go pretty much anywhere. We added then a few sort of requirements ourselves as well. We felt that it'd be quite useful if it could work daytime and nighttime, and of course tunnels comes into that as well, where there's no light. Driver-only operation as well. The more people you have that are critical to delivering a service, the more likely it is to fail. So we didn't want to have technicians or anyone else on board that had to be turning things on, turning things off, telling the train where it is, this, that and the other. We just want the driver to get in, start the train up, don't do anything else, just drive it and it to deliver. And the other key thing, of course, is it's reliable. If it's not reliable, people lose confidence in it from day one, and it's going to be rubbish forever, even if you then make it reliable in the future. So, coming on to converting the trains, what do we actually do? So, on the left-hand side there, you've got a Class 153 ex-East Midland Railway train. Why did we choose them? Basically because they were available to meet that criteria, so they can go anywhere and do this, that and the other. There's loads of trains kicking around in scrapyards and what have you, but there aren't many single coach diesel trains that have good route availability. Fortunately, they were around, so that's what we chose. On the right-hand side of that picture, you can see the pod that's mounted each side on the front of the train that looks down on the rail. So within there's lighting, and there's two cameras mounted in each. One camera mounted in each of those pods, so two cameras either side. You've got the forward-facing video on the front of there as well, and you've got the thermal camera, and you've got some forward-facing lights. So that was the sort of first incarnation of the train that was built about 3 years ago now, and that was initially went into service as that for that trial. Going under the train, on the left-hand side, you've got the Vista track geometry system. And out of those two tubes that you see there, you have a laser that comes out of there that picks up on the gauge corner of the rail, and from that determines what the geometry of the track is. On the right-hand side, we've got the rail lock locational system, so that's what tells the train where it is. 2 years ago, I couldn't really explain how that worked. I still can't really explain how it works today either. It's all black magic basically. But it takes an image of the ballast. It develops a ballast fingerprint, and from that, as long as if the ballast isn't changed significantly, it can work out where it is and where it's got back to, so you get that repeat accuracy all the time. Very, very good system, and has certainly proved to be sort of very successful so far. So coming under the train, coming back inside the train. We've got the generator there, that's the big yellow box in the middle there. You can see the air intakes on the side of the train to allow that generator to sort of keep cool and breathe and everything. You've got the exhaust coming out of the top. To the left-hand side, you've got the battery banks. So that's the UPS system on the train. That generator is constantly charging those batteries, which then powers all the equipment that's on board. Quite an intelligent charging system, so when the train finishes its run, it parks up. The generator will keep running to keep them batteries charged, so that's ready to go next time. Also, so it can get all the information off of the train at the end of the shift as well. And also it will monitor those batteries when the train, so if the train shut down for a couple of weeks, something like that, it will monitor those batteries and it will kick in again to charge them up so it's ready to go next time. You've also got some racks of gubbins there on the right hand side, which basically takes all the data, beams that up into the ether, and then it gets it onto the AVA system. So in terms of evolving, like I said, from day one, we were in sort of constant discussion with the end users to make sure that we got it right. And the first feedback, a little bit disappointing for me, was, well, it's okay, but it could really be a bit better, to be perfectly honest with you. And the feedback that we got was what could have been better was the images of the forefoot were two images stuck together, and there was a lot of feedback that really didn't work, and people were struggling to get their hands around it when they were using AVA. So there was a need to improve that, needed a single view of the forefoot. There was quite a lot of variation between the image, I wouldn't say image quality, just the image between day and night running. So at night, you were getting the artificial light and the images based on that, whereas at the daytime it was generally the natural light that was sort of the prevailing light that was being used to generate those images, and there was quite a lot of variation between it. So we had less variation between day and night running. Requirement to have a straight down view on both rail heads as well. So if you remember going back to those pods, they were both sort of looking in from the side slightly. There's a view that wanted a sort of straight down view of that. So what that resulted in, it was basically taking those pods off the front, taking the air tanks off the bottom of the train and moving them into the car body, and then putting this array that you see here on the train, so actually underneath the train itself, so it's always getting a fairly consistent amount of light, and moving from 4 cameras to 7 cameras, so 3 cameras on each rail, one looking directly down in the forefoot as well. So you've got camera looking at the web on each side of the rail, one down on the rail head, and then one in the forefoot as well. And that's the final specification that we now have in service today. So further involvement involved listening to our train maintainer and train operator as well, to improve basically the reliability and the operability of it as well. And working with Laram, who maintain the train, we've built up a sort of level of strategic spares. We've undertaken some generator mods as well and done the vehicle maintenance instruction rewrite as well. Still a little bit further to go. I think those who work on Southern, and probably recently we've had a few failures of the train where it hasn't been working as it should. Still a few more steps to take to get a bit further in terms of where we need to be, I think, with reliability, but certainly they're performing better than a number of other trains in the IM fleet at the moment. Also, to be successful, we absolutely need drivers to want to drive these. Otherwise, we always end up in a situation where there's no driver available because they want to go and drive something else, or they don't really want to come in on overtime. So did quite a lot of work on making the train pleasant and involved the drivers to give us feedback on that. As you can see there, we've got a breakout area, there's a kitchen area as well, and we've done a proper toilet and everything installed. And also done a number of cab modifications as well to make it much more comfortable and appealing to drive. Also put some bulkheads in to separate the generator area away from the breakout area as well, to make that a bit quieter as well. So, are we in it for the long haul, I suppose? Well, yes, we definitely are. This isn't a temporary thing. I know that, a lot of trials never actually go anywhere, never actually become BAU. Now that that's sort of been proven over the last 2.5 years to be a success, Network Rail is investing a lot of money into it to make it a sustainable service for the next sort of 10 plus years. Currently going through a vehicle overhaul for each of the trains. As you can see, that's pretty extensive. A lot of corrosion and paint work being done to them, but also bogie overhauls, new wheels, various electrical work and whatnot inside the train as well. But also key to this is having long-term contracts in place with the supply chain as well. So the people that look after the kit that's on the train, the people that drive them, the people that maintain them, to get their commitment and to get their sort of long-term buy-in as well, to make that, like I say, a sustainable service. So where are we today? So we have a VIU on Southern and a VIU on Eastern, and we've got the track condition monitoring unit. As you'll see, there's a intended mistake there. It should be TCMU. We've got that, which is currently running around on Eastern under trial or under commissioning, and that basically consists of a VIU train coupled up to a Class 153 PLPR train as well. Now, like I say, that's being commissioned at the moment and should be in service by mid-year, which will then give Network Rail increased PLPR capability, basically. Pretty much same functionality as a PLPR train. One of the bigger PLPR trains also has that VIU coupled to it as well. Reason why the VIU is coupled to it is really to provide resilience should you lose one of the engines on one of the units. Coming soon. So, the existing Class 150 track recording unit, which tends to be used for measuring geometry on the lower used lines, that is pretty much life expired. Was out of service for a while with some faults, but we're replacing that with a Class 153 TRU, which should hopefully be more reliable and provide us with that sort of provision for the next sort of 10 years as well. That should be in service by the end of the year, and that will have the full capability of the existing TRU plus the ability to do the S&C inspections as well. Early 2025, we should have a VIU coming online for Wales and Western, and then by late 2025, a spare VIU for resilience purposes to allow some of these other units to be maintained, but continue to provide the provision to the routes and regions. And then by the end of CP7, we should have VIUs in place for both Scotland and for North West and Central as well. So what can they do for you? So this is basically, I mean, they can do what we originally intended them to do. So you can do a BVI from your desktop at the moment using the footage from one of these trains. The current standards allow you to do alternate between doing it with a train or doing it manually. That's what the standards actually allow today. There's an aim to increase that to 3 out of 4 inspections, depending on the S&C condition and the maintenance history of it. They can operate at 70 mile an hour. They can operate at day or night. All the recorded data is available for you to view on Ava. So as soon as that train sets off, as soon as that's in motion, all of that data that records is there for you. It's not just the S&C data. You've got the downward facing video of the railhead, you've got the 4-foot view, you've got the forward facing video, you've got the thermal, you've got the geometry trace. With the geometry trace, that doesn't today include exceedances, so that is a compliant, accurate trace that you can use and make decisions based on, but doesn't include exceedances yet, but that is coming soon, hopefully within the next sort of 3 months, something like that. Locational accuracy, that's down to around about 30 millimetres at the moment, so, you know, sort of smashed that 1 metre accuracy out of the park, and generally people are getting data within 2 hours of the run being completed, so well within that 24 hours that was originally set out. But of course, things always comes with challenges, and this has been a key one. So we've had lots and lots of problems with graffiti because of the nature of these trains and where they're running. They tend to be stored or stabled in sidings in the middle of nowhere, which are quite remote, and we've had a number of occasions where we've been hit by graffiti, and of course if that's offensive or if that's very extensive, then basically the train has to be taken out of service, which is very, very frustrating. Another challenge has been route compatibility, particularly gauging. It's a very onerous process, and there's only so many people that can do it. We've got a very good relationship with the gauging engineers now, but that is quite often that we end up in a situation where computer says no, even though, as this picture shows, this is at Liverpool Street where the computer had said no, quite clearly it would fit there. So done a lot of work with the gauging engineers to try and open up more areas where the trains can run and get through that route compatibility process. The process for trade union engagement, I would say, has been quite challenging as well, particularly because it's quite sort of grey and misty, and we don't really I'm unclear as to what that process really is. There seems to be lots and lots of different opinions. Should it be local? Should it be national? Still not quite there with that. We're making good progress. We've done a lot of engagement. It just hasn't been greatly focused, which I think has been a shame. And then finally, I think cyclic paths is the key one. Getting cyclic paths into the working timetable. That makes it much easier for everyone. If we know that that's working to a 4-weekly cyclic path, everyone is prepared for it, ready for it, rather than having to put lots of effort in to do specific paths each time that's run. That's been hard work. We're making progress. We're starting to get there with that, but I think a bit of a learning exercise for everyone that's been on the project, in that we probably should have had more people dedicated to that from day one. We've sort of probably left it a little bit late, and that's caught us out a little bit. So, I'm quite an old dad. Got a 7-year-old son. He had this for Christmas. When I was a child, Lego seemed to be quite straightforward, but now it seems to be much more complicated, and the bits seem to be a lot smaller. That's possibly because of these glasses. I spent a few hours with him on Christmas Day building this, and he seemed to be pretty pleased with it, actually. And I'd say I felt quite smug, because I thought I'd actually achieved something which was quite good, building something out of Lego. But by Boxing Day, it turned into this. So he turned it into zombie dinosaur attack truck, is what he called it. So the zombie dinosaur attack truck. Remember this, John? You might want to take this away. Now, why did he do that? Because he felt that's what he wanted, and that's what he needed. He didn't have any fires to put out, but he did have lots of zombie dinosaurs to attack. Now, you're probably thinking, where the hell am I going with this? Well, my belief is that you give people something half decent, and that must be half decent. You can't give them something rubbish. Give some people something half decent that works, and they will exploit it and do more with it. Far more than that was ever designed with to do in the first place. Far more, in fact, than any business case or any benefits case can demonstrate at the start of the project before you've got something like physical in your hands. They'll use it to overcome their own specific challenges. And I think this is a cracking example of that. So, John, the message to take away is Class 153 VIUs are just like Lego. Right, wrapping up with some examples of where they've been, the data coming off the trains has been further exploited. Have I just jumped on 2 slides? Yes. Sorry, jumped on 2 slides. So covering for IM runs that have failed. So where PLPR or geometry has failed, VIUs have jumped in and covered that. Not ideal, I know, because it doesn't give exactly the same outputs as those trains do, but would certainly give a TME, section manager, whatever, information to make an informed decision on. Bonded inspection, so we were asked to get one down between Paddington and Didcot, I think it was, on the Great Western Main Line, to do some bonded inspections. Did all lines in 2 shifts, I think it was. Probably would have taken absolutely weeks to do that manually. Supervisors inspections as well, so where there's been challenges with access or challenges with sickness, we've again run the 153 in those areas to do supervisors inspections as well. So again, not what was originally intended for, but making good use of it as well. So they were all using sort of out-of-the-box data streams, but you throw a bit of sort of artificial intelligence into the box, and the capability rockets sky high. So using data collected automatically now, you can tell where certain signs are, as you can see on here. You can tell various different things, where there's vegetation encroachment, where there's, in fact, scrap rail. So I will get the hang of this by the end. Yes. Scrap rail, good example. So at the touch of a button now, it will show you exactly where all your scrap rail is. So you touch of a button, big long list in Ava of all scrap rail locations that have been identified automatically by the system. You click on one of them, and I'll show you the location of it, and it'll give you a photo of it as well. So there's no scrolling through reams and reams and reams and reams of video imagery. It's literally there at the touch of a button. Joints. Obviously, we should have some hot weather around the corner at some point, so this should be topical. Again, at the touch of a button, it will identify all the joints that you have where the train has run. You then sort that into what types of joints they are, so it can just show you where all your IBJs are. You can click on that, up comes an image. In many cases, it'll be possible to do that inspection of that IBJ from your desk. So let's just assume that 80% of those IBJs that you look at from your desk don't need any action. I'd say, what's it going to take, 1-2 minutes to do that inspection for each IBJ? Let's say 20% of them do need some action. Let's say their T-piece is damaged, rail end batter, maybe the plates are cracked, whatever. So if 20% of those need some action, before you even actually leave your desk, you know what's wrong with them, you know what materials you need, you know what tools you need to take to site, you know exactly where it is, you've got a photograph of it, and you've got the geometry trace as well. The potential for that must be to save thousands and thousands of hours every year, boots off ballast. And also, you touch another button, and you've got your gap as well. Boom! All of this is available now to people on their desktop. And I think that's just an absolute game changer. Coming back to wet beds, as was mentioned earlier. So, you can also automatically detect wet beds as well. Again, not scrolling through loads of footage, press a button, show you where the machine has detected where all your wet beds are. And again, of course, it comes with the geometry trace for that area as well. Also, low ballast. So any areas where there's low ballast, again, throws it all out automatically, detected by the machine, no scrolling through to find it. Railhead defects. So vertical longitudinal splitting. So this is quite an interesting one, because not only can you, will the actual system tell you where there's potential for this occurring, because that's looking at changes in the actual railhead running band. You can then look at the web of the rail as well, and you can determine from the rail running mark, the rolling marks on the rail, what the age of the rail is as well. And there's more and more stuff in the pipeline as well. Things like cables, automatic identification of cables, catch pits, blah, 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 loads of stuff. Also, just recently, another camera has actually been inserted onto or installed on the train that looks up, and from that you can do your basic sort of annual visual inspections of tunnels as well. So again, not needing to go on site with your binoculars and all that good stuff, just run the footage from there. No AI in that at the moment, so that's just a video run through, but maybe AI could be coming in the near future. So, thank you very much for your time. That's me. I could go on and on, but I mustn't do. But we will be at Rail Live on the 19th and 20th of June with a blue train. So if you're around, please do come and see us. Thank you very much.